Okay, so we just got done saying on paper that actually, even though this is two objects now, really we shouldn't be dealing with too much of a big difference. So let's start by sort of taking our entire first algorithm as a basis. And you can kind of see here how once you get going in Grasshopper, Dynamo, and computation, things start to really speed up because we don't have to spend all of our time worrying about setting up the infrastructure. So let's grab these two pieces that represent the mouth, and let's see what happens if we run them through our script. So what comes out the back here? And lo and behold, this still works. Why is it still working, though? Let's kind of investigate what's going on here, right? So what's interesting is we are still getting, again, we got a curve, two curves here, right? And we're getting the midpoints, and we're getting their endpoints, right? So actually, what do we end up with is one polyline curve, which is closed, and it looks all funky, yeah? And it still gets a centroid. So we're winning mostly via luck, that we did not intend for this to work in this manner. But it still abides by the rule, right? So we do have two different curves coming in, and we boil them down to a series of points, which just so happen to work for this particular algorithm. Recall that we had before a different algorithm here, which was rotating this thing about a point which was coming from two different points on the line. So let's just kind of recreate that. So had we chosen a different algorithm, so for instance, I think before we're drawing a line that kind of went between 2 points, maybe at point 8 and point 3. Refer to that previous video, yeah? That one, if I just go ahead, we had drawn a line. Now we're getting two lines, and we had said that basically the midpoint of that line, so that would be point on curve rather. So we had said before roughly the midpoint on that line would be the centroid. But in this situation, it's not the case, right? It is absolutely not the case that that would work because now we get out 2 points. So we don't, in this algorithm, had we chosen that one, the polyline command wouldn't magically work. It just magically works at this point, right? And we can see kind of what it's doing and why it works. But the magic really comes down to you have this very forgiving algorithm here called polyline, which just takes in points and chucks you out a closed curve, which then happens to work with this area. And in this one, it's less forgiving because now it will still give you out two lines, which will give you 2 points, which will, let's see if it works, give you out something that looks more like a mustache than it does a smile. So in this case, this is just a good way of showing that in this algorithm, we didn't mean for this particular way of working to be more robust than this way. We had originally talked about it being like this. However, it works. There's nothing wrong with it necessarily. But it is very important to realize that it is all about, again, chapter 1, what does the computer see? And this one, again, looks identical to you versus the original files 1, 2, and 3. And although the algorithm works, it just is by chance. Logically, we should know that actually this will not work because there's no reason, going back to what we said before, that this should work. It just happens to work on this particular chance here because this is a more forgiving methodology than this one. So again, it might have broke your script depending on if you followed these tutorials to the T, but again, it's really about understanding what data has been given.